Welcome. The purpose of this video is to help you out with homework 1 from stoichiometry, working on grams to moles. I'm going to do the first two asynchronous problems for you in this video. My recommendation for using this video is that you try both of these problems on your own, and then you come back and watch a video. And either if you got stuck, I can help you get unstuck in the video, or if you just want to double check your work. That's also a good use of the video. You shouldn't start with the video because you really should try these problems on your own first. You're going to learn more deeply if you've tried this by yourself. All right, so let's go ahead and jump right in here. What's my first step in any problem? My first step is very simple, to read the problem out loud. It forces my brain to slow down enough to make sure I'm not missing anything. So, this balloon contains 14.7 grams of helium. How many moles of helium does it contain? All right, I've read the problem out loud. My next step is to make sure I'm seeing the chemistry that's happening in my mind. So how am I going to do that? Well, I'm going to use this balloon. They've already kind of drawn it for me. And I'm going to draw out what's happening. I have a bunch of helium atoms in the balloon. I'm going to double check. Is there anything else in the balloon? No, it's just telling me about the helium. So there's no other types of atoms in here. There's no mixture. I just have helium. And the other information they've given me is that there's 14.7 grams. So I've read the problem out loud. I've pictured what's going on from a chemistry perspective. Now we can dive in and start problem solving. So firstly, I need to figure out the unit that I'm starting with. Well, I have a value that's in grams, so I'm starting with grams. Cool. Then what unit do I need to end up in? I need to end up in moles. All right, so these two pieces of the table, I should get directly from the problem. I should be able to read the problem and pick out the unit that I start with and the unit I need to end up in. Now you need to do some thinking. Maybe open up your All Stoichiometry Overview document, take a look at all of the conversion factors that we've learned and that we're going to learn. Is there one conversion factor that can move between grams and moles? Luckily, in this case, there is. Molar mass moves between grams and moles. How do I know? Well, because the units for molar mass are grams per mole. All right, so I need to look up the actual conversion factor for this case. How do I find the molar mass of helium? Well, I go to my handy dandy periodic table. Please notice I'm using the periodic table from the data booklet. Please also use the periodic table from the data booklet because otherwise you'll get used to a different periodic table and then we'll take a test and you'll have this periodic table which gives you probably less information than any periodic tables you've seen online, only gives you the symbol for elements, so please get used to this periodic table. Don't Google one, don't use a physical periodic table you have. This is the periodic table you should be using. In this way, all of our significant figures will match. So, helium has a mass of 4.00 according to my data booklet, which is the periodic table I'm using. So, my molar mass, which in this case is 4.00. What's the unit for molar mass? I just said it. Hopefully you said out loud to yourself, grams per mole. How did I know that molar mass was relevant here? We'll take a look. Grams and moles are my units, and then I see grams and moles are the units I'm dealing with. Sometimes a problem isn't so nice. Sometimes I can't convert directly from one unit to another, from the unit I'm starting in to the unit I need to end up in. Sometimes I need to convert from one unit to another unit to another unit. But in this case, there is a conversion factor that goes directly from grams to moles, So there's only one conversion factor. There's only one step that I'll need to follow. Okay, pause for a moment. Make sure that you're with me. If you have any questions at this point, pause the video, re-watch, use the homework document, send me an email, tag me in a comment, and let's dive into problem solving. So, starting value, I always start dimensional analysis with the amount given. What is the amount given? The quantity given, 14.7 grams of helium. All right, the next step, people always want to multiply and divide and do some math, but before I do any math, I'm going to deal with my units. So I'm not going to plug in any numbers. I'm going to deal with my conversion factor and make sure my units are working. So my conversion factor, I wrote that too big, I'm using is molar mass. I'm going from grams to moles. And so let's see how I should put those on the conversion factor. I see grams in my starting value. That means that I need grams in the denominator of my conversion factor. So grams matches up with grams. All right. Well, I know I'm moving into moles, so I set this up. And then I'm going to check myself. Did my units work? I see that grams of helium is going to cancel with grams of helium. I'm canceling units, not numbers necessarily, but I'm canceling units. I see I end in moles of helium, or I should say I have moles of helium on top, meaning the only unit left in my problem is going to be moles of helium. And that's good. That's the unit that we wanted to end in, was moles of helium. So I see that I've set my units up correctly. So I haven't put any numbers in, I've only added the units, and just by doing that, I can see that I'm going to do this problem correctly. Now I'm ready to add numbers. All right, so I have this magic number of 4.0 grams per mole. Another way to write that would be 4.0 grams for every 1 mole. So let's see what number goes where. Well, if I have grams right here, what number was next to grams in my conversion factor? 4. So 4.00. And then I have moles here, moles here. What number is next to moles? 1. So 1 mole. I'm going to make sure that those numbers make sense. For every 1 mole of helium, I have 4.00 grams of helium. All right, that matches up. That is my molar mass. In this case, I'm using the relative atomic mass because I have a single element. So that checks out. If you had flipped those numbers, you would have written 4 for every 4 moles of helium, there's 1 gram of helium. That doesn't work. For every 1 mole of helium, 4 grams of helium. So I've put my numbers in the correct spot. So now I have a relatively simple math problem. 14.7 times 1 over 4. I'm going to erase my unit for now just to give myself some space. So I've just pulled out my numbers that I need to multiply. I'm going to put this into my calculator. And I come up with 3.68 moles of helium. Excuse me. Let's just draw a box around this. So I see my ending unit again was moles of helium. So I end up in moles of helium. All right, stop. Ask yourself any questions you have, add them to the homework document, tag me in a comment. You've now successfully converted from grams to moles. Let's go ahead and do number 2. Number 2, look around the room you are in. There are approximately 0.56 moles of hydrogen molecules surrounding you. What is the mass of this amount of hydrogen molecules? All right, so step 1, I've read. Step 2, I'm going to draw myself a little picture. This time they didn't give me a picture, but I'm going to draw myself a picture. This problem is about a room that I am sitting in. Here's my room. There's me. Happy because we're doing stoichiometry. And they're telling me about the hydrogen molecules. So let's draw in the hydrogen molecules. Hydrogen is diatomic, so it exists as H2. There's, of course, other molecules in the air, but we're just worrying about the hydrogen for now. And they tell me there's 0.56 moles of hydrogen. All right, so this time the unit that I'm starting in is moles. The unit that I'm ending in is grams. Again, my conversion factor to go between moles and grams, either grams to moles or moles to grams, is molar mass. In this case, let's determine the molar mass of H2. This time we'll have to use the relative molecular mass. Hydrogen, I can see here, each hydrogen atom is 1.01. Relative atomic mass, I have 2 of them in H2. So 2.02 grams per mole is the molar mass. Another way to write that, 2.02 grams of hydrogen over 1 mole of hydrogen. I'm going to write that same thing here, and I'm going to write it as a conversion factor just so it's really easy to see. Over 1 mole. All right, let's go ahead, do our problem solving. What do we always start dimensional analysis with? The amount given. What's my amount given? 0.56 moles of H2. All right, I'm starting with moles, so where do moles need to go in my conversion factor? This time moles are going on the bottom. Why do moles need to go on the bottom? So that I can cancel moles and moles. Moles are on the bottom, grams are on top. In this case, I'm going moles, 2 grams, again using molar mass. But this time, instead of grams to moles, I'm going moles to grams. And I see the unit that I'll end in is grams. That's great, because I was looking for mass. So the unit for mass should be grams. Notice again, I'm starting with units. I'm not starting with numbers, I'm starting with units. Now that I know my units are going to be correct, I know I'll get this problem correct as long as I put my numbers in correctly. So let's go ahead and do that. I see I have this conversion factor here, 2.02 grams for every 1 mole. I double check that these units make sense, and it does indeed make sense that there's 2.02 grams for every 1 mole. 2.02 grams for every 1 mole. And so now, again, I have kind of a simple math problem. It's going to be 0.56 times 2.02 over 1. And I'll put this into my calculator. 0.56 times 2.02. I end up with 1.13 grams of hydrogen molecules are in the room. So if you look around the room that you're in, you have about 1.13 grams of hydrogen surrounding you. Kind of cool, right? Let's box that in. All right. I hope that helps. Make sure that you keep going here. Make sure that you are feeling totally confident on grams to moles and even adding in particles. Notice that for none of these problems did we need to use Avogadro's number. You only need to use Avogadro's number when you're looking at the actual number of particles. So notice just to go from grams to moles is one conversion factor. So keep working on this homework. Make sure you're feeling totally comfortable with all these problems, and we'll move right along. Have a good day. Bye.